Do bell curves and z-scores confuse you? Then this video is for you. In the medical world, physicians view people in two groups: those who are healthy versus those who are sick. Different medical tests confirm that diagnosis. Healthy people demonstrate a narrow range of test values. Their test results, when placed on a graph, form a symmetrical bell-shaped curve. The bell curve immediately divulges valuable information. The peak tells us the average test value for the entire population. Using a statistical equation, the bell curve can be marked with lines called standard deviations. Standard deviations depict the percentage of people having test results falling to either side of average. 3 standard deviations, either side of average, include 99.8% of all healthy people. Values straying outside that range identify illness. Another way to discover information within a population is to study the shape of the bell curve. Not all curves are symmetrical. Asymmetric curves can unmask valuable insight. For example, what caused the skewed tail on this bell curve? And what does mode, median, and mean tell us? And why are those values divergent in a skewed bell curve compared to the symmetrical one? The mean is simply another term for average, and nearly everyone knows that the average is calculated by adding all the numbers in a set and then dividing that sum by the number of items in the set. The median identifies the number falling in the exact middle of a set. In this example, 9. That means there are an equal number of values to the right and left of the median. The mode is the number appearing most often in a set of numbers. In this example, 3. The use of these terms can prove useful, as shown here. Observing the skewed bell curve hides information until the mean, median, and mode are entered. The mode illustrates that nearly 50% of patients remain in hospital for 3.5 days, while the median defines a length of stay of 4.1 days. That is, the number of patients with less than 4.1 days in hospital equals the number of people with a longer stay. Interestingly, the average length of stay was about 4.8 days. The long tail on the graph drives the average to the right. If we study only large data sets, we can miss valuable information. Like my dog, we need to search the pool to uncover hidden data on specific targets. In medical studies, to focus on specific individuals, we use z-scores. A z-score for any individual is calculated by subtracting the population mean from that individual's test result and then dividing that number by the population standard deviation. This example illustrates a z-score for a blood test with a normal range of 80 to 120. The normal data pool has a mean of 100 with a standard deviation of 10. If a person has a test result of 115, the z-score is calculated as 1.5. That calculated z-score is then positioned on a bell curve, marking exactly where the person resides on a spectrum of health. I hope this tutorial proved useful, and I thank you for your attention. Please feel free to learn more information on population health management by visiting our website at kychealth.com.